Dear students, I have come with a new module, Computation of Coefficient of Variation. This is an important module and we are using this for all the statistical studies or all the social science studies or all the research work. So we will be extensively using this, and that is the importance of this module. So we have standard deviation is the absolute measure of dispersion. The corresponding relative measure is coefficient of variation. So standard deviation is the best average for measuring the variation because it satisfies all the measures for computing a good measure of variation. So the relative measure of coefficient is the coefficient of variation, and this also will have the advantages related to standard deviation. And this method is also developed by Carl Pearson and in 1893. Now in 2021 also we are using this method and we are learning this. That means that is the importance of this module and it's the importance of this measure what we are going to learn. So most widely used measure of relative variation and used to compare the variability of two or more series, performance of two companies, performance of two students, performance of two players, or anything we can compare with the performance. Then any measure of dispersion can be used for computing relative measure of dispersion. And statisticians use standard deviation as the measure of dispersion and arithmetic mean as the average. Though any method can be used, statisticians world over they are using standard deviation and arithmetic mean for computing coefficient of variation. So the relative measure of dispersion is the coefficient of variation, and coefficient of variation is stated in terms of arithmetic mean and standard deviation. Our computation is also based on standard deviation and arithmetic mean. So resulting percentage is known as coefficient of variation or coefficient of variability. Whatever the coefficient of variation value, we will multiply with 100 and always we will express it as a percentage value and use widely for comparing two or more groups of data. Now, interpretation is very important because I told you we are using this variation for comparing the performance. If you are comparing the performance of two companies or if you are comparing the performance of two students, anything, we are expressing as percentage and we have to interpret the data properly. So the series or group for which coefficient of variation is greater is said to be more variable. That means if we are getting a high value for computation, then it's high variation among the values or the distributions. That means less consistent, less uniform, less stable or less homogeneous. Whereas if the series for which coefficient of variation is less, if your computed value is a small value, then it's said to be less variable, more consistent, more uniform, more stable, more homogeneous or more predictable. So denoted by the symbol CV, and formula is CV is equal to standard deviation divided by x bar into 100. Now one problem we will do. The scores of two batsmen A and B in 10 cricket matches is given below. Using coefficient of variation, find whether batsman A or B is more consistent in scoring. So A has scored 32, 28, 47, 63, 71, 39, 10, 60, 96 and 14 runs. Batsman B 19, 31, 48, 53, 67, 90, 10, 62, 40 and 80 runs. Now we have to compare the performance. So computation for batsman A, we have to remember, we have to calculate x bar, that is the mean. We have to calculate standard deviation, then we have to substitute the values in the equation. So values of x are there, then we have to take the mean value we have to take. Mean value is total of x divided by number of observations. So 460 divided by 10, that is equal to 46 runs. Now standard deviation, actual mean is not in fractions. So we can use the 46 and we can take the deviations. So we are taking the deviations and we are taking the total FD square total, we are getting 8460. So this deviation totals is 8460. So standard deviation is sigma d squared divided by n minus sigma d by n the whole square, and we are taking the square root. So sigma is equal to root of 8460 divided by 10 minus 140 divided by 10 square, that is 25.495 runs. When you substitute the values for computing coefficient of variation, 24.495 divided by the mean value 46 into 100, 55.42 percentage. Now we have to calculate for batsman B. So same computation, mean we have to calculate and standard deviation we have to calculate. So x values are there, x total is 500. So 500 divided by 10, it's 50 runs. Now standard deviation, we have to take the deviations and we have to take the d square values we have to take. So d square value is 6968 divided by 10 minus d values, total of d value is 100 divided by 10 squared. So we are getting 24.43 runs. Now coefficient of variation is equal to standard deviation divided by mean into 100. That is equal to, we will get 48.86%. Now we are coming to the most important thing, that is interpreting the data. So you have to write the interpretation like this. What is the coefficient of variation value for batsman A? That is 55.42%. The value for B is 48.86%. So coefficient of variation is less for batsman B. So he is more consistent in scoring. This is an important interpretation. So interpretation is very important for coefficient of variation, and you have to write it like this. Both the values you have to write it again, and then the final thing will be the conclusion, what you are concluding as the interpretation. Now one more problem we can do, that is an analysis of the monthly wages paid to workers in two firms A and B belonging to the same industry gives the following results. So firm A and firm B, number of workers 500 and 600, average monthly wages 186 and 175, variance of distribution of wages 81 and 100. So which of the firm A or B has a larger wage bill? Second question is, in which of the firms A or B there is greater variability in individual wages? Now first question we have to calculate, that is wage bill of the firm. That is equal to, we can compute using the equation, number of workers into average monthly wages. So for firm A it is 500 into 186, that is rupees 93,000. Firm B 600 into 175, that is rupees 1,05,000. Now firm B has a larger wage bill because firm B bill is 1,05,000, whereas firm A it's only 93,000. Now the second question we can calculate variability is compared with the coefficient of variation. Now we can calculate variation, always we are using coefficient of variation. So CV is equal to standard deviation divided by x bar into 100. So root of 81, variance is square root of standard deviation is variance. So root of 81 divided by 186 into 100, that is 4.8387%. For firm B it is root of 100 divided by 175 into 100, 5.7143%. So firm B coefficient of variation is small, that is 5.7143 is high. Coefficient of variation is high for firm B and it's less for firm A. So firm B has greater variability and firm A has less variability. So that is the interpretation. So this is what I want to explain with this module. Thank you.